All right, well, I trust you did well on that quiz just now. Those in here, for the most part, felt they did well. A couple confident people thought they got 100 on it, so we will see tomorrow when we grade it. For now, I want you to look at these 3 problems on the chalkboard, and these are all binomials being divided by other binomials. And I said that in some select cases, a binomial and a binomial could be divided by inspection. That is, we look at the problem, we do no math at all, we do the work in our head. We literally just write the answer. That's all that goes down on paper, or in this case on chalkboard. And I said there's 3 times it can work. Here's the key. Whatever you got here has to be the same thing you have here to some power. Whatever you have here has to be the same thing you have here to the same power as you had before. Furthermore, depending on the way the signs themselves line up, the signs in the answers could be different. Depending on the way the signs work, the exponents may have requirements placed upon them. So as we look at the first problem, do I have matching terms with matching exponents, class? Yeah. A's match, B's match, 6th powers match. What's the rule for a difference divided by a sum from the poster, class? Well, that's in the answer, the signs are going to alternate, but what's the rule for it to actually work properly? N has to be even, and of course N represents the exponents that are being used. Well, we have even exponents, so I can just go. And remember how we start writing our answer. How do we start the answer off? I actually showed an example of it a moment ago when we were going over the homework. I did one of those by inspection. Volunteer, Noah? The power below. So we're going to start by writing what? There we go. How many thinking the same thing Noah said, just not confident enough to raise your hand? All right. Then we start 1 power less than here. We take the very first value and we descend it, starting a power less than what the exponent says up here. All right. Now, somebody else show of hand who's going to volunteer. How do we do the next step in the process? He took the A and descended it. Somebody else going to continue it for us. Audrey. Where? In this term? Yeah. In this term. Because technically we start with the B, or the second value, gone. Then to the first, then... And then where the A was gone, the B is to the 5th. By the way, notice the exponents. 5, 5, 5, 5, 5, 5. Right? And then the last step, of course, is to put in your signs. In class, we already said the signs are going to alternate in this case for the difference divided by the sum. But we said the first term, class, is always positive. So then from there we'll put in. Do we have to write the leading positive sign? We don't have to. It's not wrong to, though, if it helps. And there we go. We write our answer. Now, how many like, okay, yeah, I remember this from yesterday now, just had to get my memory refreshed, okay? Where's the problem? We look at this and I see an M, I see an M, I see a 2. I don't see a 2. I see a 4th power. I don't see a 4th power. Thoughts, Maddie? 2 to the 4th is 16, so it's really just a matter of rewriting so that you can literally see the 2 and see the 4th. At your seats. Do likewise based on the poster. See if you can get the answer. Most of mathematics is identifying patterns. Patterns lead to shortcuts. Here's a great shortcut once you get the pattern. Volunteer for the answer. Thank you, Abby. Abby, what did you get for your, in case you can't tell, she didn't volunteer. Abby, what did you get?
M cubed positive 2m squared positive 4m positive 8.
And it's perfect. M cubed, squared, first, gone. 2 gone, first, squared, cubed. And when you've got differences You could have even or odd powers, it doesn't matter, and all the signs are going to be positive. Anyone else get the same answer Abby got? Just, also too scared to raise your hand like Abby? Those who didn't get it, does it make sense now that I've gone over it? Questions on that? Look at the next one. I see an R, I see an R. I see an S squared. I see an S. I see a fifth, I see a 10th. Thoughts on maybe how I could rewrite something here, Michael?
You could do S to the 5th times 2.
You got the right idea. Somebody maybe help him even that out a little bit. Brandon?
S to the 5th to the exponent of 2.
So, S to the 5th squared. So here I see an R, here I see an R, here I see an S squared, here I see an S to the 5th, here I see a 5th, here I see a squared. We're really close.
You square the R and the...
Abby's got her hand up this time.
The 5th over S.
Okay, we have an R, we have an R. We have an S squared, we need an S squared. We have a 5th, we need the 5th. So you had the right exponents, and you were thinking that. We just need to flip-flop them. So the R's and the S squareds match, and the outer exponents match. Does that make sense now? All right, now at your seats. Again, using the poster, get your answer. This is leading somewhere, by the way. Not today, but in a few days, we're going to come back and hit this. You're like, oh, that's why he taught that to us. It's not in your book, but it's an important skill to know. Michael's got an answer. Brandon has an answer. Maddie has an answer. Now I gotta call on you, Maddie. Maddie, what did you get for your answer?
R to the 4th negative R cubed S plus R squared S squared negative R cubed positive S to the 5th.
Really close. So if you took the R that you see here, and we went power less, 4, 3, 2, 1, gone. Here's the only difference. It's not an S down here. It's an S squared. So we actually need S squared, S squared squared, S squared cubed, and S squared to the 4th. First of all, how many have the same answer Maddie had? Because that's an answer I expected several people to have. All right? How many remembered there was really an S squared that was being first squared cubed 4th? Anyone remember that? All right, so Noah, let's modify Maddie's answer slightly. I'm going to keep the alternating signs, which she got correct. I'm going to keep all of her R powers, which were all correct. But help me with the S's.
S squared, S to the 4th, S to the 6th, and S squared.
There we go. S squared to the 1st, S squared squared, S squared cubed, and S squared to the 4th. Does that make sense? Just that little detail. How many had this answer that Noah had? Only Noah. Great job, Noah. Questions from the rest of you. Questions from the rest of you. Noah found grace in the eyes of the math teacher. He got the right answer. Questions on this? So I could rather find grace in the eyes of the Lord. It's true. It would be better. All right. Anyway, we're going to revisit this topic a little bit later. Next section in your notes. Next section in your notes. And those who had me for Algebra 1 or have had a good Algebra 1 class in the past know how important this next topic is going to be. And it's the topic of factoring. Next section in your notes, factoring. Again, from Algebra 1, you'll recall that when in doubt, factor just seemed to be the way things worked. Everything we ended up doing at some point seemed to come back to, oh, well, if we can factor, we can do this. Factoring is one of the most foundational skills in algebra. But what is factoring? Well, let's take you back to your elementary days when you learned that 10 was equal to 2 times 5 and equal to 1 times 10. So the factors of 10 are 1, 2, 5, and 10, but they would factor in these pairs, right? That was factoring. Whereas you could do the same thing with algebraic expressions. For instance, 3 times x would be 3 times x, right? Or 4a plus 4b would be 4 times a plus b if you distributed. And we're specifically going to look at factoring polynomials. Go ahead and finish the heading in your notes. Factoring polynomials. And why did I just write it out instead of doing p-nom? I don't know. All right, factoring polynomials. Factoring polynomials. You know that 3xy times x plus 4y squared, we could distribute. And when we distribute, what do we get for our answer here? Genesis?
Positive 3x squared x plus 12xy.
There we go, right? All of you should have been thinking the same thing. We've talked about distribution already. Well, you realize that if this times this equals this, then I should be able to take this expression and break it back down into its parts. Just like you learned 2 times 5 was 10, and a couple years later in elementary when your teacher talked about factoring, you put it in reverse. You started with the 10 and said, wait, I can split that into 2 times 5. The same thing. You learned how to distribute or multiply. I should be able to take this and recognize, well, both terms have in them a 3. Both terms have in them an x. Both terms have in them a y. And just like if you started with the 10 and maybe your teacher said 2 times blank, you could have thought, well, 10 divided by 2 equals 5. And technically you would divide one factor to get the other. So write this in your notes, factoring in algebra is division also. Just write down factoring is division. Factoring is division. And so once you've identified, for instance, well, I know there's a 2 in 10. Divide to get the 5. I've identified a 3, an x, and a y in each of these terms, so we would divide to get the other factor. Divide sign, number, letter class to get x. Divide sign, number, letter class to get positive 4y squared. But instead of showing with the raised dot, we'll show it with parentheses. And we're right back where we started had we chosen to distribute. Factoring. You see that really this is simply dividing something. The key is you've got to figure out what's the common factor. What is that initial factor? For instance, you're like, oh, 10. Oh, let's factor that into 3 times something. I mean, technically 3 1/3, I guess. But, you know, if we're thinking integers, nice numbers I like, we don't want to divide by a 3. 3 is not an integer factor, right? So here identifying what's common. Write this down in your notes. nx plus ny minus nz. nx plus ny minus nz. If I want to factor this polynomial, I first need to look at every single term and ask myself, self, what is in every single term? In class, obviously, what's everywhere? N. And so I'm going to write n as my what I call common factor. And then I'm going to put parentheses as opposed to the raised dot. I'm going to divide out the n, and everything that's left would be my other factor. What's left if I divide sign, number, letter, sign, number, letter, sign, number, letter, Michael?
X plus y minus z.
X plus y minus z. And I have factored the polynomial. Now, how would you check if you really wanted to check? You would distribute nx, positive ny, negative nz. Boom. Write this in your notes. Factoring out a common monomial factor, is the opposite of distribution. Factoring out a common monomial factor is the opposite of distribution. Factoring out a common monomial factor is the opposite of distribution. The difference is you have to figure out what is the initial monomial. Well, as we look at this, what number is in every term, class? 3. What letter is in every term? A. Now here's the question. How many A's are in every term? Well, here there's 2, here there's 1, here there's 4, but all of them have, here's the key, at least how many A's, class?
1.
At least 1. What if this had been an A to the 5th? Now they all at least have 2. What if this had been a 7? Now they all at least have 4. Let's just roll with where we're at now. Since they all have at least 4 A's, I'll pull that out. Any other letters common? No, almost an X, but there's not an X here, right? So that's okay. 3A to the 4th is my common factor. And then we remember that factoring is division. What do I get when I divide sign, number, letter 1, 2, 3 times? What is the remaining polynomial factor, Maddie? How many thinking the same thing Maddie said? How many remember doing this in Algebra 1? Anyone say, I don't remember doing this at all, but it makes sense now? Okay, so a few of you are like, I don't remember this, but it at least makes sense to you. All right, write this one down. 7n squared p minus 14n squared p squared. At your seats, I want you to identify what is the common monomial. What is the common monomial factor? So little tiny fly, and I finally got it. Okay, at least I got one of them. I think there might be more. I'm going to name that one Gavin. Just kidding, just kidding. It was a little tiny bug. If anything, I shouldn't go there, should I? Now Audrey's shaking her head and be like, don't do it, Mr. Nadasky, don't do it. Okay, I won't. All right, what is the common monomial here, Audrey?
2b.
There's a 2 everywhere?
No,
It's a 7. There's a 7 everywhere. What else is everywhere? A p is everywhere. What else is everywhere? And n squared is everywhere. How many identify that 7n squared p is everywhere? And what we're going to do is put our parentheses and we're going to divide sign, number, letter once, sign, number, letter twice. Back to Audrey for redemption. We're going to divide sign, number, letter the first time, Audrey. What do I get? Well, they cancel completely, don't they? But when you divide something by itself, you always get 1. And that's why I wanted to show you this example. When you factor something out of itself, you get 1. For instance, if we go back to 10, like, I don't want to factor 2 times 5. I want to say 10 times something. Well, because you're factoring something by itself, the other factor is always going to be a 1. Same thing happens here. But we keep going, Audrey. Sign, number, letter a second time.
2.
Negative 2p. Don't forget the sign part of it. Sign, number, letter, negative 2p. And I think you were kind of a step ahead of me when you said 2p earlier, negative 2p earlier. You were thinking of that part there. How many have this now? Questions. Look in your textbooks, page number 20. Look in your textbooks at page 20. Look at the yellow shaded box. Example 1.4a. Page 20, yellow shaded box. I'm going to keep you just a little bit past the bell. Not long, I promise. Page 20. Look at the yellow shaded box. They give you, here's another bug. Got him. Okay. One in that one, bracket. Just as long as you don't name one Kendall. Anyway, all right, letter A. Notice they give you a 3r plus 6. Notice there's a 3 that's common, so they write that first. And in parentheses, they divide everything by the 3 and get r positive 2. Any questions on A? Look at letter B. They have 12q cubed. That's a fun one. Minus 24q squared. Notice there's a 12 common and a q squared common. They divide by the 12q squared, get a q, minus 2. Questions on B? Look at letter C. Ooh. They have a 12x times the quantity m plus 2 minus 5 times the quantity m plus 2. How many terms is that, class? 2 terms. Notice that each term has a quantity m plus 2 in it. So they factored out a quantity m plus 2. Notice what was left. 12x negative 5. Questions on example C. Do you want me to show that on the board? Or do we all understand it? Anyone need to see it on the board? He doesn't want to stay late. All right, he's over there. No. Turn to page 28. Turn to page 28. Do 2, 4, 6, and 10. 2, 4, 6, and 10 on page 28. Two, 4, 6, 10 on page 28. finished. Noah's finished. He's like, no, I just heard the bell ring and put my pencil in. Don't be a slob. Okay, Audrey. Also, don't be absent from school, or you might get a gnat named after you posthumously. Pencils down, even if you're not finished. Pencils down. Looking at the first thing, I see there's a 4 in both of them. You say, well, there's a 2 common. Yeah, but we want the biggest amount possible. 4 is the bigger number. We're going to factor out 4, dividing it x, -8, we're done. Looking at the next one, I see that there's a 3 in both terms and at least 2 x's, so x squared. You divide 6x cubed by 3x squared, you get 2x. You divide 3x squared by 3x squared, class, they cancel to give you +1. Excellent. Here, I see there's a 7 in both. I see there's at least 3 x's in both. I divide sign, number, letter to get 2x squared. I divide sign, number, letter cancels to get a -1 this time. And on the last one, I have 2 terms. Both terms have what in common, class? W minus 12. And if I take the W minus 12, imagine me ripping it off the chalkboard, what's left after I've factored it away or divided it away? 3v plus 7z. How many got all 4 of these correct? You got all 4 correct. All right, questions on any of these? Homework for this evening, you're going to do the odds in the same little section, page 28, 1 through 11 odd. Page 28, 1 through 11 odd. And then on page 29, I want you to do numbers 2 through 36, the even, but you can skip number 32. It's a triple distribution. You've already got one other one in that section. I don't want to waste your time tonight. You need the other practice. I don't think you need that much extra practice on that concept. So page 28, 1 through 11 odd, and page 29, numbers 2 through 36, the even, but you're skipping number 32. Have a wonderful rest of your day, and you are dismissed.